Yo, it's another nostalgic math chat. Um, IEB May 2023 paper 2. It's very interesting to me that almost the whole paper is something that I personally subjectively would classify as level 3, level 4. Um, and I think it's pretty much just like how I find with paper 1, there's lots of rules that you can remember that can make most of the problems almost rote. So like with quadratic equations, you need to get all your terms onto one side, leave the other side as a 0, and then from there you plug it into the quadratic formula, or you can factorize. So it's pretty standard ways of solving things. Whereas with paper 2, with topics like Euclidean geometry and also what we're going to look at today, 3D trigonometry, there isn't like really a very straightforward rule book like that you can apply to the problems. It's kind of, you get given this toolbox and then you can combine the tools in it in a number of creative ways to arrive at a solution. There's a little bit of intuition that comes into the question where you just have a feeling that you might need a tool like this, etc. So I think paper 2 is a little bit different from paper 1 in that way. And I think that's why I'm ending up making more videos on paper 2 than I did on paper 1. It's just because it feels like paper 2 has fewer questions that have like a standard approach, if I can call it that. Anyway, wow, this really did become a ramble, true to the channel's name. But let's actually get to some substance. So, I've already given away that we're looking at a 3D trig question. Let's look at the details. In the diagram below, ADC represents a horizontal triangular field. Cool. BD represents a vertical building standing on ADC at D. I just love this. Like, it really gives me a nice visual in my head, because I think visualizing in 3D is also like quite an interesting task. Anyway, AC is 120 meters. I'm just going to go ahead and write that down. DAC is alpha. Okay, that they've given us. ACD is beta. Just give me a sec. Right. And then the angle of elevation of B from A is theta. Right. So the angle between that that the line BA makes with the ground. Just as a very not accurate way to say that, but hopefully it gives me a good idea of what that last line is saying. Right, and that is theta. So we are asked to determine the height of the building BD, so this guy, in terms of alpha, beta, and theta. And you must simplify your answer, so that will be possibly using your sine, cos formulae, or SOH CAH TOA reduction formulae, more importantly. I don't know why I went to SOH CAH TOA. Anyway, so we are trying to get here the triangle where we have the most information is this one, right? We've got the length of AC, we've got alpha, we've got beta. So we need to try and get from this triangle to that triangle over there. So how shall we do it? We do it. So instinctively, right, I want to then get an expression for this side, right? Because it's a side that appears in this triangle and also in this triangle, right? And remember we said, we want to go from this triangle, the information heavy triangle, to the triangle where the the side BD appears. Oh, and that's actually a place to kind of highlight why work with this triangle and not this one. And that's just because we look at where there's more information. We have been given pretty much nothing in the triangle BCD. So really, do not play there unless you're desperate. Right, so back to the mission. Going to try and get an expression for the side AD so that I can then move into this triangle. So let me just make a note for myself because goldfish tendencies. So in the triangle ADC, we have this side and we have two angles and we're trying to get that guy. So very important to note up front, we don't know if triangle ADC is right angled or not, so we can't use any SOH CAH TOA type machinations, right? So we're pretty much looking at either the sine rule or the cosine rule. The cosine rule works well when you have three sides and you're trying to figure out one of the angles, or if you have two sides and the included angle. So if I had, for example, this side and this angle, then the cosine rule would be perfect for me to figure out what that side is. Alas, we do not have the data, right? So that leaves me feeling like the sine rule might be a good candidate here. And sine rule is nice when you have a side, the angle opposite to that side, and then another pair of angle side like that. So in this case, we're interested in this side, and we know that the angle opposite to it is beta. So this leads me to think that, you know what, let me express this angle in terms of alpha and beta, because then I have this angle and the side opposite to it, and then I can equate it to the ratio between sine of that angle and this side. Okay, I hope that'll make more sense as I write it down. So the first task is to express ADC, right, in terms of alpha and beta. And we know that ADC will be equal to 180 minus alpha plus beta, right? And that is because of the angle sum of triangle ADC. Right, I'm actually going to leave it like that. There isn't really a benefit to expanding it. Yeah. Expand if necessitated by external circumstances. Anyway, right, that was just very random. Okay, so we figured out an expression for ADC in terms of alpha and beta. So now, using the sine rule, we can say it's always nice to, whatever it is you're trying to figure out, put that at the top of the fraction, right? Just makes it easier to work out the unknown. Not trying to fish it out of the denominator. It's just at the top, ready to be isolated, right? So we are trying to figure out an expression for AD. So AD over sine, oh, that went too far to the side, sine beta is equal to this guy, AC, which is 120, divided by sine of this angle. So sine of 180 minus alpha plus beta. Right. And this is yelling out to be simplified using a reduction formula. Right, so we know that sine of 180 minus a, right, second quadrant, so sine is positive, right? It's just the same as sine of a, whatever a is. So we can apply that same logic over here to say that this is the same as 120 over sine of this guy, alpha plus beta. Right. What do I want to do? What do I want to do? What do I want to do? I would like to move this and this and shrink that and just put it somewhere over here. Okay, righty. So now we can isolate AD, right? We can times both sides by this denominator, well, the value of the denominator. So we end up with AD is equal to 120 sine beta divided by sine of alpha plus beta. So that is an expression for AD in terms of alpha and beta. Right, so now we can move out of this triangle, right, and focus on this one because we want BD, right? And we have an expression for AD, we have this angle theta, and we have a right-angled triangle. So now we can use SOH CAH TOA. So we just need to figure out, well, okay, which ratio will get us what we want. So we want the side that is opposite to theta. We have the angle that is adjacent to it, so we need to use tan. Okay, so what does tan tell us? We know that tan of theta is going to be equal to BD over AD, right? And so I am not going to put this in here just yet because I would rather first get BD by itself, right? So this is just the same as saying BD is equal to AD times tan theta. Okay, so now we can bring in this big fraction, right? So that's AD. Whoa. And we're timesing that by tan theta. Okay. And that is just the same as 120 sine beta tan theta divided by sine of alpha plus beta. And that is our expression for BD. So again, not a tough question, just in terms of, you know, how tough these things get. But one of those questions where it's about strategizing and thinking carefully about which values do you need to compute, which will advance your solution, right? Because you don't want to be now working your tail off trying to get expressions in that triangle only to end up in a dead end or something, you know. So yes, I hope this was useful, as with all the videos actually. Right, stop rambling, look at memo. Question 10b, we have oh, that is interesting. Anyway, okay, so we have AD is equal to, no, what's happening? What am I looking at? So BD is equal to 120 sine beta times tan theta divided by, okay, and then they expand this well, I don't know if expand, okay, expand is not the right word, but they use the double identity to rewrite it as sine theta cos beta plus cos theta sine beta. I honestly don't know how important that is. I instinctively feel like not very important, but yeah, ask your teacher, ask someone qualified. Righty doos. See you next time.